Hello, my dear students. Myself is Pradeep Kumar Jana, lecturer in mathematics. Now we are going to start the determinant and matrix. So now, what is the power determinant and matrix? Now let us start. So now, the introduction of the determinant, the introduction, the determinant, minor and cofactor, properties of the determinant, and the application of determinant and matrices. So actually, how to derive those determinant and the matrix? Determinant matrix aim to solve by the system of linear equation. So it is derived from what you call linear equations. So determinant and matrix. So now, that how to derive those determinants and also matrices. Let us consider the system of linear equation. System of linear equation is a1x, b1y, c1, a2x, b2y, c2, and also we get from the value of x and y. The x and y exist whenever a1 b2 or a2 b1 not equal to 0. So this form can be received in the following way. This following way is called a determinant. Actually, determinant is derived from two vertical line or two parallel lines with four elements in a square. Like this, A1, B1 or A2, B2. Then that means this is a parallel line. And we arrange the four elements, that is A1, A2, B1 and also B2. It is form of a square. So that is called a determinant. Determinant always written in a two vertical bar with a square elements. That is called the second order determinant or 2x2 determinant. Similarly, we get 3x3 determinants and 4x4 determinants and I+5 determinant and also n+a determinant. Now discuss one by one the second order determinant, that is called 2x2 determinant or second order determinants. So let del is equal to A1, A2, B1, B2 in a vertical bar or parallel bar. Actually, the determinant is a algebraic term. Without symbol, we cannot say it is a determinant. That means it is always a term of symbolical mathematics. It is a symbolical mathematics. Symbolical mathematics means whenever we have to write two vertical bars but two parallel lines in a four square elements, then it is called a determinant. So it is a symbolic mathematics and the order is 2+2. Why it is called order 2+2? That means it is a two horizontal lines and two vertical lines. Two horizontal lines is called as R1 and R. Similarly, two vertical lines called as C1 and C2. And that means two rows and two columns. Two rows and two columns, that is called as 2x2 determinant. That means always row and columns in same is called a determinant. Determinants in always 2x2 or 3x3 or 4x4, it is called a determinant. 2x2 is called second order determinants, and 3x3 is called third order determinants, and 4x4 is called fourth order determinant. So now discuss the second order determinant. Second order determinants. Let del is equal to A11, A12, A21, A22. Also, I told you that is row 1 and also row 2, that is column 1 and column, that is 2 row and 2 column. So how to expand the second order determinants? Del is equal to A11, A22 is called a principal diagonal, is called principal diagonal, and A21 and A22 is called as secondary diagonal. Principal diagonal, that is called secondary diagonal. The expanding this to the second order disorder are the principal diagonal minus secondary diagonal. So that is A11, A22 minus A21, A1. That is the value of the disorder in second order disorder. As an example, let select del is equal to 1 to 3, 7. So how to solve the second order disorder? Del is equal to 1 to 3 to 3, 7. That is principal diagonal minus secondary diagonal. That is 1 into 7 minus 3 into 2. That is 7 minus 6 is equal to 1. That is the value of the disorder. Similarly, or each example, let del is equal to sin theta into cos theta minus cos theta into sin. Then principal diagonal minus secondary diagonal. That is sin square theta minus cos square theta. That is sin square theta plus cos square theta is equal to 1. That is which is solved by the second order disorder. Okay. How to get the principal, first you get from the principal diagonal, then you get the secondary diagonal. So how it is possible? First you return from a principal diagonal, then in the secondary diagonal. Why you cannot write the secondary diagonal minus principal diagonal? Why? Because it is derived from a system of linear equation. System of linear equation, that is the one of the condition, that is A1 B2 or A2 B1 is not equal to 0. That conditions is written, that conditions is written in the following way. That can be possible whenever the first principal diagonal, then secondary diagonal. Then we get the value of the determinant in second order determinant. So now go to third order determinant. The determinant of the third order determinant is denoted as A1, B1, C1, A2, B2, C2, and A3, B3, C3. The third order determinants is written like this. The third order determinant, the value of the third order determinants, how to solve, or how to get the third order determinant. Now discuss about the third order determinants. Third order determinant. Let del is equal to A1, B1, C1, A2, B2, C2, and also A3, B3, 6. That is called third order determinant. Third order determinant means it contains 3 rows, that is R1, R2, and also R3. Similarly, column 1, column 2, and column. So 3 rows and 3 columns. So it is called as third order determinant or 3 cross 3 determinants. Now, value of the third order determinant. How to get out the third order determinant? Value of the third order determinant. Third order determinants can be expanded in 6 ways. 6 ways. One is row 1, row 2, row 3, or column 1, column 2, or also column 3. The third order determinant can be expanded in 6 ways. That is, we have to expand from R1 and also R2 and also R3. Similarly, column 1 or column 2 or also column. So, how to get the result of the third order determinant? Discuss one by one. Let del or del is equal to A1, B1, C1, A2, B2, C2, and also A3, B3, C. How to expand third order determinant? Let expanding along along R1. K1, then when expanding along R1, first we write for A1 and also the omitting the one column or also one row. One column or one row. Then we get from B1, B2, C2 and B C3. Then second B1 is negative. That is minor B1 and also like this, omitting the column 2 and row 1. Then you get A2, C2, A3, C3. And similarly, the sign of C1 is plus C1. Then omitting column 3 and row 1. That is A2, B2 and A3, B3. That is expanding along R1. Second, it is contains 2 determinant and also contains 2 cross 2 determinant and also contains 2 cross 2 determinants. Now here the principal diagonal minus secondary diagonal. Similarly, the principal diagonal minus secondary diagonal, then principal diagonal, then secondary diagonal. So whenever expanding third order determinant, we have to remember like this: plus, minus, plus, minus, plus, minus, plus, minus, plus. That is the sign of the elements. Now we are discussing so how it is plus and how it is minus. So how it is minus and how it is plus. So now as we remember the expanding like this: plus, the minus plus minus or plus minus 10. And also we have to remember the crossing the diagonal wise, crossing the principal diagonal wise or secondary diagonal wise. The cutting the with again straight lines, that sign is positive. A1, B2, C3 is positive and A3, B2 and C1 is positive. And also all others are negative sign. This line is positive and also the positive. Then other sign is negative. Right. So similarly, we have to expand in row 2, also row 3, also column 1 and column 2 and column. Yes. You see how to get third order determinant expanding into third order in general form. Determinant of A, summation of k in 1 minus 1 to the power I cross k, aik. Determinant of aik is equal to this: I through cofactor expansion and z column cofactor of expansion. We get like this. It is get by the minor and cofactor. The sign of A1, B1, C1 or A2, B2, C2 and also A3, B3, C3 like this. These signs are get by the minor and also cofactor. Then generally we have to remember how to expanding the row wise or column wise like this. As sign is plus, then minus, then plus, minus, plus, minus, plus, minus or plus. Then let del is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. Now expanding R1, R2 and R3. Similarly, we have to expanding column 1, column 2 or column 3. How to get by expanding column 1? Expanding along C1. Now expanding along C1. How to expanding along C1? Del is equal to K1 pointing I through and Z column. We get B2, C2, B3, C3 minus A2. Yes, correct. Pointing A2 and also A2 row wise or column wise. That is B1, C2, B3, C3. And also, A3, expanding A3 equal to omitting like this and omitting like this. Omitting column 3, row 3, and also column 1. That is B1, C1, B2, C2. Then the principal diagonal minus secondary diagonal. Then principal diagonal minus secondary diagonal. Principal diagonal minus secondary diagonal. We get expanding along C1. Similarly, expanding C2 and also expanding C3. These are our course of second order determinant and third order determinant. Now, getting into one of the example about the third order determinant, how to solve those third order determinants. Right. And let A is equal to 1, 2, 3, 1, 0, I, 2, 1, 1. How to expand the third order determinant? Expanding third order determinant either N1 row or N1 column, what both sides result are same. So now expanding the R1. Expanding along R1. They equal to 1 into, you say, the expanding column 1 and row 1, we get 0, 5, 1, 1. 0, 5, 1, 1. That is 0 minus 5. Then the sign of 2 is minus 2. But then omitting second column, and first 2. Then we get 1, 5, 2, 1 second order determinant. That is principal diagonal minus secondary diagonal, 1 minus 10. Well, similarly, plus 3, omitting column 3 and row 1. So we get 1, 0, 2, 1 second order determinant. That can be expanded directly. The principal diagonal minus secondary diagonal, 1 minus 0. So we get minus 5 plus 10 plus 3. Minus 5 so 21. So, 16. Minus 5 plus 21 equal to 16. That is expanding along R1. Similarly, expanding along C1. Now 1 into this omitting third. So, column and R2 0, 5, 0, 5, 1, 1. That is 0 minus 5. Then sign of 1 is minus 5. Then omitting second row and third column, we get 2, 3, 1, 1. That is second order determinant. That is principal diagonal minus secondary diagonal, 2 minus 3. Similarly, expanding also 2, we get expanding third row and first column. That is 2, 3, 0, 5 second order determinant. Then principal diagonal minus secondary diagonal, 10 minus 0. That is minus 5 plus 1 plus 40 is equal to minus 5 plus 41 equal to 16. That is the only result. Expanding either N1 row or N1 column, but both sides result are same. That is, we get expanding along R1 is 16 and also expanding along C1 is also 16. Similarly, if we expanding row 2 and also row 3 or column 1 or column 2 or column 3, all are same. That is, the result of R1 is equal to R2 is equal to R3 is equal to C1 is equal to C2 is equal to C3 is equal to 16. That is expanding any one row or any one column is third order determinant.
I think so. I think the pattern is really good.
So how to expanding those third order determinant? Third expanding minus 3, then omitting first row and first column, then we get second order determinants. That is First is the principal diagonal, then secondary diagonal. We get this result. So similarly, expanding is then omitting second column and first row. Then we get the second order determinant like this 2 minus 3 by 4, 4 into 11. Then we get the result. Similarly, expanding the third elements, that is 1 by 4. 1 by 4 is expanding, omitting third column and first row. Then we get 2, 0, 4, 118. That is the second order determinant. Then principal diagonal minus secondary diagonal, we get the result. That is for first element, then second element, and the third element, we get the result 690 iron. Yellow, first row, X1, A1, B1, C1, like this. Expansion of practical problem. मतलब एक example है. A, H, G, H, B, H, G, F, C. How to solve? Then expanding only with the first row. The A into expanding, omitting first column, then third row. Then B, L, F, C. That is the second order determinant. Then minus A, H, then also G. Then we get from the determinant. Second order expanding, the second order determinant. I mean expanding any first row and also second row, also third row, or first column, or second column, or third column, the result is always same. That is ABC plus 2FG minus AH square minus BG square minus CH square. देखिए ये प्रैक्टिकल जो प्रॉब्लम दिया है ये के बाबा मैजिक डिटरमिनेंट है ये हैंडसम गर्ल having a beautiful face going for college. That can be expanded like this. ABC plus 2FGH minus AH square minus BG square minus CH square. So how to solve the determinant of 1, 2, 3, 4, 5, 6, 7, and 9. Then we can expand like this any one row, row 1, or row 2, or row 3, or column 1, column 2, or column 3. Then everybody we get the result of the 0. The extension of third row determinant like this. It can be obtained by the minor and cofactor of the determinant. Now we have to discuss then is equal to A1, B1, C1, A2, B2, C3, A3, B3, and also 6. That is the R order determinants. Determinant is expanded in any one row or any one column, then similarly we get the result. That result is the same as any one row or any one column. And also the R order determinant can be expanded in another way that is given by Horo method. Sorry, the one of the scientists who is how to solve the third order determinant in shortcut. Or that method. How to solve those in shortcut method. That is row 1, that is row 2, and also row 3. That is column 1 and column 2 and column 3. So now we have to write the column 1 and column 2 in right hand sides. Here, del is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. Then we have to write the right hand side for two columns, column 1 and column 2. That is K1, A2, A3, B1, B2, and also B3. Okay. So now the multiplying in diagonal wise K1, B2, C. And also plus B1, C2, A3. And also C1, A2, B. So that is K1, B2, C3 plus B1, C2, A3 plus C1, A2, B. Then downward is plus and upward is minus. Minus and minus and also minus. That is get which is sign of plus and also get minus. Then that is minus of del is equal to K1, B1, C1, A2, B2, C2, and A3, B3, C3. Oh, I told you the path to write for our C1 and C2 in right hand side. That is A1, A2, A3, and also B1, B2, A3. Right. So there has to be multiplying downwards. That is downwards. Downward or downwards. So taking the sign of A1, B2, C3 plus B1, C2, A3 plus C1, KU with this. Then minus. Upward all are minus. Upward all are minus. That is K3, B2, C1 plus B3, C2, K1 plus C3, K2, B1. Downward is positive and upward is negative. So now let us take one of those example is 1, 2, 3, 2, 1, 4 and 3 to 5. The how to solve? The downward is plus. Now multiplying 1 into 1 is 5 equal to 5. Then 2 plus 4 into 3 equal to 24. Then 3 into 2 equal to 12. Okay. So these are which is plus 5 plus 24 equal to 12. 5 plus 24 plus 12. Then upward is 3, 1 and 6. So we get 9. Then 2, 4 into 1 we get 8. Then 5 into 2 into 2 equal to 12. So now the downward is positive and upward is all are negative. So taking the bracket, so all are positive and then all are positive. When open the comma sign, then all are comma get all also get negatives. So the adding the 5 to 24 and 12, we get 41, then minus, then 9, 8 into 20 is equal to 37. Then we get the results 41 minus 37 equal to those results. Meaning of those minor. The minor of an element, any one of the element, the minor of the elements can be obtained by deleting ith row and jth column. Deleting the ith row and jth column. Well, how to get those minor? Minor is denoted as Ij. That means it is ith row and jth column. Let del is equal to A1, B1, C1 and A2, B2, C3. Then that's A3, C3, A3, B3, 6. So how to get the minor? The minor is often 3 plus 3. 3 cross 3, that means 9 elements. How to determine what is the 9 elements? We get minor up to 9 elements. That we get into the minor of A11 and also B1 or C1 or A2, B2, C2, A3, B3, C. Well, how to get minor of A11 or B11 or C11, but also A11 or so you because let del is equal to A11, A12, A1, A21, A22, A23. A actually for each A11, A12, A13, A21, A22, A23, A31, A32, and also A3. That is third order determinant in general order. So A11 means the first row and first column, and A12 means first row and second column. So A13 means first row and third column. Similarly, A21 means second row and first column. a second row and first column. A22 means second row or second column. That is second row and second column. A31 means third row and first column. Third row and first column. It contains 9 elements. So we get formula, the minor of formula, all are formula 9 elements, formula 1 by 1. So now, have to get the minor of A11. A11 is written as A11. A11 means ith row and jth column. A11 means we have to delete ith row and jth column. That is A22, A23, A32, A33. The value of the comma M11 is the principal diagonal minus secondary diagonal. That is minor of M11, but that is A11. Similarly, the minor of A12 equal to A12. A12 means we have to get the A12 delete ith column and jth row. We get A21, A23, A31, A33. Now expanding M12 equal to the principal diagonal minus secondary diagonal. Similarly, suppose we have to get minor of M22. How to get M22? Now, omitting ith row and jth column. Ith row and jth column. So that is get A11, A13, A31, A33. Then principal diagonal and secondary diagonal. The minor of order determinant we get A11, A12, A13, A21, A22, A23, A31, A32, A3. We get 9 minor of formula, 9 elements. Low sign is given by the minor of formula M112 up to M3. These are minor of 3 plus 3 determinants. So now, the one of the example is let del is equal to 104 11105. How to get the minor of 9 elements? Suppose we have to get the minor of 1. Minor of 1 is A11. M11. How to get M11? The omitting ith and jth column. That is 1105. Now, the get the value of M11 equal to principal diagonal minus secondary diagonal. That is 1 into I minus 0 into 1 equal to I minus 0 equal to I. So similarly, if you get the minor of M12, that is omitting the ith row and jth column. That is 1115. The principal diagonal minus secondary diagonal. That is 1 into I minus 1 into 1. That is I minus 1 equal to spot. If you get minor of A33, same 33 means I. Omitting ith row and jth column. Ith row and jth column. That is 1011. That is principal diagonal minus secondary diagonal. That is 1 into 1 minus 1 into 0. That is 1 minus 0 equal to 1. Similarly, we get the formula minor of formula M11, M12, M13, M21, M22, M23, M31, M32, and M3. So that is we get 9 minor of third order determinants. So how to get formula minor of formula third order determinant M11, example you can M21 or M33. The expanding like this. So then discuss about cofactor. How to get those cofactor of those third order determinant. The R is a cofactor. How to get cofactor? Cofactor. Cofactors of an element. Cofactors of an element. Cofactors of an element A, I, J of a determinant del, then can be obtained by multiplying minus 1 to the power I plus j with a I j. Then that means Cij means symbol of cofactor. Cij equal to minus 1 to the power I plus j with a I j. That is the cofactor of our elements. We get 9 cofactors of a 3 plus 3 determinant. Similarly, the cofactor also obtained by those 9 elements. How to get those cofactor of an elements in our determinants? Let us discuss one by one by our example. Let del is equal to 1, 0, 3, 1, 1, 1, 0, I. That is third determinant. The minor is of 9 elements. Similarly, the cofactor is also of 9 elements. Now, the cofactor of formula 1. The cofactor of C11. C11 is 1 equal to minus 1 to the power I plus j with m I j. I means I throw, j means j column. I throw is 1 and j column is 1. That is minus 1 to the power 1 plus 1. M I j omitting I throw and j column. That is we get 1, 1, 0, 5. 1, 1 and 0, 5. So minus 1 to the power minus 1 square. That is principal diagonal minus secondary diagonal. 1 into 5 minus 0 into 1. Then that is I minus 0. That is we get I. Similarly, we can get the cofactor of C12, C13, C21, and C12, and C13, and C31, and also C32, and also C33. That is the 9 cofactors of 9 elements. Cofactor is also written like this. That is Cij. Cij equal to plus Mij when I plus j equal to even, and minus Mij when I plus j equal to or. And then also the cofactor can be obtained by the following way. Cij means cofactor of any elements in 9 elements. When adding ith row and jth column is even, then we get plus Mij. When ith row and jth row is added or, then minor is taking as minus. When even, then taking as plus. When I plus j or, then taking as minus. For example, let del is equal to 1, 0, 1, 2, 1, 0, 3, 1, 0.
Right here instead.
So now, the cofactor of 1. The cofactor of 1. Cofactor of 1 means C11. C11 means ith row and jth column. Ith row and jth column. I is 1 and j is 1. The adding I plus j, we get even. So, when even, taking plus sign of minor. Minor only with plus sign. Then taking minor. A11 means omitting ith column and jth row. That is 1, 0, 1, 0. Then that is principal diagonal minus secondary diagonal. 0 minus 0 equal to 0. Okay.
Then that's it.
Similarly, to find the cofactor of 0. That is C1. Now adding 1 plus 2 equal to 3. If you are when odd, then taking the minor is minus. Also minus. Then pointing I throw, and just then 0, 8, that is principal diagonal minus secondary diagonal minus 0 minus 0 equal to 0. If you go any elements, then negative sign is multiplied. Then when it is 0, then the minus is automatically omitted. So similarly, we get the cofactor of 1 equal to C13 and cofactor of 4 C21 and also cofactor of 1 C22 and also the cofactor of C31 and then C32 and C32. That is the minor and cofactor of the determinant. So now how to get the other determinant? Sign is plus, minus, plus, or minus, plus, minus, or plus, minus, plus. When it is obtained, that sign is element is plus or minus. Why it is plus or minus? By using the minor and cofactors. Minor and cofactors. Using the minor and cofactors, we get one plus and also minus, also plus, minus, plus, minus, also plus, minus, and plus. How to get plus, minus, plus, or minus, plus, minus, plus, minus, plus. So the next class, we have to discuss how to get the sign of each and every element in why it is plus and why it is minus. Okay. Thank you all of you.